In this video, we'll be discussing vector operations. For any real numbers a, b, c, d, and k, if you want to add vector ab plus bc, all you do is add the a coordinates together and the b coordinates together. So I still think of it like ordered pairs, so I think of adding the x's together and the y's together. We get the vector with coordinates a plus c, comma b plus d. If we are multiplying a vector by a scalar, we simply distribute that scalar to each component of the vector. If vector A is equal to a1, a2, then the opposite of vector A, or negative A, is equal to negative a1, comma negative a2. And then our operation number 4 there just has to do with subtracting vectors. So I did it the long way, listed it out, and showed how we changed subtraction into adding the opposite, which we've discussed in a previous video. But basically, when you are subtracting two vectors, you subtract the x components and the y components. So let's perform some operations. Vector u is negative 2, 5, and vector v is 4, 3. Let's start by finding u minus v. When subtracting vectors, that property number 4 shows us that all we need to do is subtract the two first components, subtract the two second components. And you certainly do not have to write out all this work. I'm just trying to be thorough for you. We end up with the vector negative 6, 2. In our next example, we want to find negative 5 times vector v. All we're doing here, per our property number 2, is we're just distributing that scalar to each of these components. We end up with the vector negative 20, negative 15. In our part C here, you'll see that it is a little bit more involved, but we're going to follow order of operations that rules everything in math. Notice that we have scalar multiplication, and then we also have addition and subtraction. So following those order of operations, we'll do the multiplication first. So let's start by finding 2 times u. We're just distributing 2 into the components of u, so that's going to become negative 4 and 10. Now plus v, and v is just how it is, so that's going to be 4, 3. And now, so the next one's minus 6v. Rather than distributing the 6 and then having a minus in between my vectors, I'd be inclined to distribute that negative so then I can just add them up. Oh, distributing a negative 6 into v, we get negative 24 and negative 18. And now we're ready to combine, and since it's all addition, I just need to add all my first components together and all my second components together, and that'll be my answer. Oh, adding our first components together, that's 24, and then our second, negative 5. So we have the vector negative 24, negative 5. We can also talk about the horizontal and vertical components of a vector. The horizontal and vertical components, respectively, of a vector v having magnitude magnitude of v and direction angle theta are given by a equals the magnitude of v times cosine and b equals the magnitude of v times sine. So that means that a vector AB can be rewritten as the magnitude of v times cosine I plus the magnitude of v times cosine j. So we're just replacing from our regular AI plus bj. There's our b and j. So where these formulas come from, I'd like to show you because they make sense. So say I have some vector here, AB. So we're out here at the point AB, and I'm going to make a triangle because when we're in that AI plus BJ, we're looking at a triangle. So down here is A, and this side is B. Here's our angle theta. And the hypotenuse is the magnitude of V. So now let's just think SOHCAHTOA for a minute. Cosine of theta is equal to our adjacent side over the hypotenuse. And then if I solve this equation for A, multiplying both sides by the magnitude of V, we get A is equal to the magnitude of V times cosine theta. And that's what we have right up here for our rule. Similarly, if we do sine of this triangle here, sine is equal to opposite over hypotenuse, and then we solve for b, we get b to be equal to the magnitude of v times sine of theta, and then that's the other part here of our rule for horizontal and vertical components. So that's where it comes from. It's just coming from SOHCAHTOA. You'll definitely want to remember those, but if you forget, you can always derive them. So let's find the horizontal and vertical components of vector v if alpha is the angle of inclination from vector v from the horizontal. So alpha is 50 degrees. The magnitude of v is 26 degrees. Don't try to make this hard, just plug it in. Our coordinate A is going to be equal to 26 times cosine of 50 degrees. And let's round to the nearest hundredth here. So that's going to be equal to 16.71. B, it's going to be 26 times sine of 50 degrees. Plugging that into our calculator, rounding to the nearest hundredth. We're going to get 19.92. So that means that our vector 16.71 comma 19.92, or if we wanted to write it in our AI plus BJ notation, it'd be 16.71I plus 19.92J. Usually I use the angle brackets until there's a reason to rewrite it in the AI plus BJ form.